lesson, we are going to continue with lesson 2 and 3 of recurring decimals. The first thing you needed to do was to fill out this table, and there's two key definitions. One decimal is terminating, which means it doesn't repeat after the decimal place, and one is recurring, which means it goes on forever. You can either use a line or a dot. The best way to do this would be to create a line above the number by underlining something. Now, if you don't know how to convert fractions into decimals, there are two ways of doing this. The first way is to use a calculator. So I am going to use my calculator on my computer. It would be better if you used a calculator in person. So what we're going to do is we're going to write the top number or numerator divided by the bottom number or denominator. 1 divided by 4 is equal to 0.25, and then we ask ourselves, is that terminating or recurring? If it is terminating, you need to just leave the length of repeat blank. We repeat this process for the rest of the table, being sure you're filling out both the type and the length of the repeat as well as the decimal. Now we are going to have a look at a couple of the questions. Before we do that, we're just going to talk about how the dots work for decimals. So if we have 0.34 and it continues such that we've got 0.34343434, we need to put a dot above 3 and 4 or a line across the whole thing, because that's what repeats. However, we may get some differences in the following questions. It says we need to use the decimal division of a fraction spreadsheet. This has been sent to you on Hangouts. To find some values of 1 over n when the repeat is 1 less than n. So basically what we want to say is if we have 1/7 is the repeat 6. If we have 1/8 is the repeat digits 7. If we have 1/9, are there 8 repeated digits? How can we get from n to 1 less than n? That's just by minusing 1. So you can see, once you've made a copy of this worksheet and put it in a lovely place in your Google folder, we are going to get the following. So if we change this to 1/7, you're going to see that the number of digits repeating is 6, and that is exactly why 1/7 is so special. If you keep changing the fraction, so it's 1/7, 1/8, 1/9, 1/10, what other instances do we have that the number of digits repeated is 1 less than the number on the denominator? So for example, for 11 we've got 2 digits repeating. 2 digits is not 1 less than 11, therefore it doesn't satisfy this pattern. And you can continue this process by changing numbers. Check for 19. Does 19 work, for example? Now we need to consider the remainders. Explain why the length is the case. So for the remainders, it's how much we carry each time. Let me just show you. So for this bit here, we can see the remainders are 110, 110, 110. So try and talk about what is significant about the remainders. What's the minimum number? What's the maximum number? What pattern do you notice? How does the pattern cause how many digits that are repeating? Now we're going to go on to section B. Again, this time we're filling out the table, but we're filling out the denominator of 11. Same as before. Then we do it for 13, making sure that you complete both the length and the repeating digits. And you should be able to notice a pattern here. So we're going to repeat the process now with 31. This time you can see the 0 and 9 are repeating, so we put 0, 9 with a line above the top. Then it says you need to go back to all the recurring decimals we found and do something else. I'm not going to tell you too much about the rest of the investigation. But what you need to make sure you're doing is hitting all these criterions. You need to make sure you're writing full sentences and you are achieving each of these things. If you haven't achieved these things, you will not get full marks in your investigation. Good luck, and remember to use both this document and this document.